Hello everyone and welcome back to the channel. Today we are going deep into one of the most impressive engineering achievements in modern history.
The Panama Canal expansion. This is not just a canal. This is not just a waterway. This is a giant machine built into the landscape. A system of concrete chambers, rolling gates, water-saving basins, control rooms,
tugboats, and massive ships moving with unbelievable precision. And in this video, we follow the final transformation of this enormous project.
This from construction completion to full operation. Look at this scene from above. The entire complex looks almost like a giant.
On one side, we see the long rectangular water-saving basins.
Built to store and reuse water during each lock cycle. In the center is the main navigation lane,
where Neo-Panamax vessels are guided through the chambers step by step. Every surface has a purpose. Every wall holds pressure. Every gate must move at the exact right moment, and every meter of this structure has to work together. At this stage, the construction crews are no longer shaping raw land.
They are completing the final details, paving the access roads, installing handrails, finishing drainage channels, testing lighting systems,
cleaning the concrete decks, and preparing the site for real commercial traffic. This is the moment when a construction site becomes an operating mega project.
The first major focus is the lock entrance.
The guide walls must be clean, straight, and strong enough to lead some of the largest ships on Earth into the chamber safely. Tugboats wait outside,
ready to push and correct the vessel's position by small movements. From the air, it looks calm. But in reality,
this is a high-pressure operation where a tiny mistake can delay an entire shipping route. Then, the control systems come alive. Inside the control room, female Caucasian operators monitor chamber levels, gate positions, basin levels, vessel movement.
Wind, weather, cameras, and radio communication. The lock is no longer just concrete and steel. It becomes a living system controlled by human judgment and digital precision. When the first vessel approaches, the scale becomes clear. A huge cargo ship enters the lower approach, supported by tugboats.
Slowly, carefully, the ship enters the first chamber. The lower rolling gate closes behind it. The chamber is sealed.
And then the real magic begins. Water begins moving through hidden culverts and valves.
The ship rises or descends gradually, not by engines, not by cranes, but by the power of hydraulic engineering.
This is what makes the Panama Canal so different from a simple sea-level canal. The canal does not just cut through land.
That is why the locks are the heart of the canal. As the vessel moves from Chamber 1 to Chamber 2,
then from Chamber 2 to Chamber 3, we see the full logic of the system. Gates open only after the water levels are equal. Male tugboat operators maintain alignment. South Asian female operators communicate constantly. Caucasian male technicians monitor the basin system.
Gate machinery, power rooms, valve galleries, and emergency centers. This is not one structure.
It is an entire city of engineering working in silence. The exterior is impressive.
Behind the visible walls are electrical rooms, control galleries, maintenance workshops, dispatch offices,
sunhoi ceiling rooms, safety centers, and monitoring stations. These spaces keep the canal running day and night.
And then comes the moment every mega project is built for. The upper gate opens. The ship moves forward.
The vessel exits the final chamber.
A full transit is complete. What was once a construction zone
is now a functioning global trade artery. But the story does not end with one ship. The canal must repeat this process
Again and again. In daylight, at night, in raid, under pressure, and under strict schedules.
Each vessel requires coordination. Each lockage uses water, power, machinery, and human expertise.
Each transit proves that the entire system is working.
From the observation deck, the completed complex looks clean, calm, and organized.
But beneath that calm surface is one of the most demanding engineering operations in the world.
The Panama Canal expansion is powerful because it shows what modern infrastructure really means. It is not only about building something huge.
It is about building something huge that can operate every single day, safely, precisely, repeatedly.
Concrete walls must withstand pressure. Rolling gates must move reliably.
Water-saving basins must perform efficiently. Tugboats must guide massive ships through narrow spaces.
Operators must make decisions at the right second. And when all of that works together,
And the result is breathtaking. A massive red cargo ship glides through the lock.
Tugboats hold it in perfect alignment. The water level changes beneath it. The gates open one after another, and the ship continues its journey between oceans.
At full power, a construction project becomes a machine. A machine becomes a transport system, and a transport system becomes part of the world economy. So as you watch this video, do not just look at the ship. Look at the whole system around it. The basins, the chambers, the slopes. The service roads, the control rooms, the workers, the lights, the gates, and the hidden hydraulic structures below. That is where the real story is. This is not just the completion of a canal expansion. This is the moment a mega project comes alive.
if you enjoyed this journey through one of the world's greatest engineering systems, make sure to follow the channel.
Guys, hit the like button and subscribe for more videos about incredible construction projects, mega structures,
and the engineering stories behind them. Thank you for watching.